the cause mainly is ozone, nitrogen oxide, and the organics. So let's still focus on the atmospheric pressure. No atmospheric pollution. So we said in the atmosphere, the major pollutants are the gases. And I think we'll appreciate that there is a lot of chemistry involved. We saw yesterday the equation, how we can convert the oxides into different forms, oxygen to hydrogen peroxide, oxygen to oxygen radical, and so on and so forth. So we talk about, so in this unit, you're talking about atmospheric photochemical. So photo means we are using light, and the light is normally the UV light. And when you have these gases, they normally break down and form radicals. So the atmospheric chemistry is concerned with the chemical pathways that may lead to the removal of the gaseous pollutants. We were talking about primary, secondary pollutants like nitrogen dioxide. It can combine with water to form nitric acid, which can fall as rain. Sulfur, the same thing. Sometimes it can undergo oxidation in presence of catalyst to form nitrogen dioxide, other forms of nitrogen dioxide. Ozone can also break down and so on and so forth, yeah. So in the atmosphere, the chemistry is normally controlled by what we call free radicals and atoms. Because when you have this UV light, it is possible for these radicals to be broken, for the molecules to break down and form atoms or radicals. And the concentrations are quite high. So for these radicals, they are not very stable. That's why we say here, their half-lives are very short. They don't stay for long before undergoing transformation. So it's also important to understand the atmosphere. I think we looked at the atmosphere, talking about the various levels, the troposphere, stratosphere, mesosphere, and the thermosphere. And we said life is normally as a stratosphere, where the higher you go, the cooler it becomes, where we have the water cycle and so on and so forth. So the key thing here is the presence of sunlight, UV light from the sun, because it's the one which initiates this free radical reaction. And it normally comes from the sun. There are also other rays in the upper atmosphere, like X-ray, cosmetic rays, which can also bring about this kind of reactions. But the main one is the UV light, which breaks molecules into radicals and atoms. So let's just look at this. So when we were looking at the diagram of the atmosphere, I think we talked about the troposphere, and we say the troposphere is normally characterized by what we call positive lap rates. That means the temperature decreases as you go up. Now at low altitude, the temperature is hot. The higher you go, the cooler it becomes. So this encourages the air to mix. And so we have called, so hence photochemical reactions. So what we have is during the cold air, we have the conventional process. And then this air now mixes because of the different temperatures. We know when it is hot, it becomes lighter, it goes up. When it is when it's hotter, it's become lighter, it goes up. When it is cold, it's heavier, it comes down. So this allows the mixing of the same. So we were talking about the tropopause. The rate of the vertical mixing falls sharply, and as you go up, we say the temperature increases with increase in altitude. So there were regions in the atmosphere where we say the higher you go, instead of it becoming cooler, it becomes hot. And I remember when we talked about thermosphere, we say it's a region which is characterized by very high temperatures. So, so in terms of the pollution, these processes are difficult to control because of the variation in temperature. And what brings about the mixing of the air is because of the change in density as air moves through regions of different temperatures. So low temperature in the up, so the low temperatures are normally for the troposphere are normally up. Sorry. Sorry. Let me just fix something. My laptop. Sorry, the power of my laptop was going off. Let me just go back and share. Okay, so I think we were talking about the effect of these temperatures and their significance. And some of these things that we are looking at today could be a repetition of what we discussed yesterday. So we talk about the troposphere. So here again we have high temperature, and most of the temperatures reactions are controlled by free radicals. So we talk about photolysis. Photolysis are reactions which are generated by light, photochemical reactions. So I remember we talked about this reaction where ozone in presence of UV light can break down to form molecular oxygen plus water. And we say this molecular oxygen, not atomic oxygen, can combine with water to form hydroxide radicals. So ozone diffuses into the troposphere from the stratosphere where we have life. And what happens is that the oxygen radicals are important for oxidation of most of the pollutants. So you can see in the second equation, the carbon monoxide, when it combines with the hydrogen, with the hydroxide radicals, what you get is carbon dioxide plus water. So it oxidizes carbon monoxide to carbon dioxide, and in the process it gets reduced to hydrogen atom. The same, so the M here is a catalyst. Remember yesterday we said M is a catalyst, a third body. We are putting it there because it doesn't change. By the end of the reaction, it's just converted to M. When it reacts with nitrogen, these are examples of oxidation which are catalyzed by OH. So we have, when we have nitrogen dioxide plus OH, it can combine with the hydroxide radical to form nitric acid, and we know nitric acid, when it combines with water, it falls down as acid rain. For sulfur dioxide, again, it can be oxidized by the OH radical to form the sulfate ion plus. So it can be, so this one can be oxidized to form the hydrogen sulfide, and this one can be oxidized further with the hydroxide ion to form a sulfuric acid. There's something wrong with the equation. Some things have been mixed a bit here. So it's supposed to be HSO3, and then the HOSO3, when you combine this with OH, that's when now you get your sulfuric acid. The -3 there, I think, should not be there. That charge should not be there. So you have two reactions here. Sorry about that. So you have SO3 plus OH to give you HSO3. These are radicals, and then when you combine these with another OH, it gives rise to the sulfate. So you get the sulfate. The same can also oxidize methane. So methane, when it's oxidized, oxidation here, we look at it as removal of hydrogen. It can form a methyl radical plus water. And so what we are saying is that in the above reaction, they will always lead to the removal of hydrogen carbonate, of hydrocarbons from the atmosphere. So most of these hydrocarbons in the atmosphere, they will react with the free radicals, and they'll undergo a series of chain reaction in presence of a quencher. A quencher is a chemical that controls the reaction. So the quenchers in this case are methane, OH, and the methyl radical that you generate as the product during the reaction. So the reactions that we are talking about is essentially common at low temperatures. So the reactions is essentially a low temperature combustion process. And when you look at the product that we get here, the product will normally be carbon dioxide and water. So we get carbon dioxide and water from the oxidation of these organics. So we can also look at the other gas in the atmosphere is sulfur dioxide. So how is this one removed from the troposphere? So again, the same process. We know that this one is fairly soluble in water. So under wet conditions, it can react with water to form sulfurous acid, or by reactions in liquid phase. So the dry sulfur dioxide can also undergo oxidation. So it can undergo oxidation, and the reaction is given here. When it is oxidized, it picks up oxygen in presence of a third body. You form what we call sulfur trioxide. So you can oxidize sulfur dioxide to sulfur trioxide through oxidation. So here we can see the reaction is being carried out by oxygen. It can also be oxidized by ozone, where ozone gives out one oxygen. In the process, you get sulfur trioxide and oxygen gas. And this reaction can continue and continue. So you can also, so the same oxygen that is formed here can also react with the sulfur dioxide in presence of UV light to give you a sulfur trioxide. And we can also be able to represent this reaction just as we did up there, that this OH can also react with sulfur dioxide in presence of a third body, a catalyst, to form hydrogen sulfide. So this is how sulfur dioxide can be removed from the atmosphere, just through the reaction of oxygen, ozone, no, atomic oxygen, ozone, oxygen gas, and even hydrogen, the hydroxide radicals. So we can have it being converted to various forms. And what we appreciate here is that whatever we are forming here will be soluble in water. So we have, when you have water in the atmosphere, it can dissolve the same, and the same can fall as acid rain. So we talk about acid rain. Now, the other gas that we mentioned in the atmosphere is NOx, or the oxide of nitrogen. And we normally have two forms. Remember, we said we have the NO, which is the nitric oxide, and then we have nitrogen dioxide, which is the NO2. And we said these are the major pollutants in the atmosphere. Remember, we said NO2 has a brown fumes when we are talking about the photochemical smog, where there is, which affects the visibility of the atmosphere. It is normally caused by nitrogen dioxide. And then there is also another one, N2O, nitrous oxide, or the laughing gas. So this one is relatively inert in the atmosphere, but it can also play a very important role in the stratosphere where we have life. So it can take part in the reaction in terms of picking up atomic oxygen. When you say sink, the sink is something that will act as a medium that can receive pollutants from the atmosphere. So the major ones are NO and NO2. So these ones, remember we said they are rapidly interconverted. So that means NO can be oxidized to NO and NO can also be oxidized to NO2. So we said in presence of UV light yesterday when you talk about formation of smog, photochemical smog, we say light can break down NO2 to give us NO plus oxygen. Now in the dark, when we don't have too much light, NO can pick up oxygen to form NO2 or nitrogen dioxide. And the nitrogen dioxide that we form can also be removed by the OH radical. So OH radical can combine with the NO2 in presence of a third body, which we give it as a simple M to give us nitric acid, maybe in vapor form. And we know when this one combines with water, it will fall as acid rain. So the nitric acid is removed via acid rain. So these reactions are normally illustrated. I think we covered this one earlier when we were talking about photochemical smog. So what we just need to appreciate is that the major radical here is the OH. It can oxidize oxygen, it can oxidize carbon monoxide, it can oxidize nitrogen oxide, it can oxidize sulfur dioxide to form the oxides which are soluble in water, and in the process, these ones will fall as acid rain. So just to review what we talked about yesterday, photochemical smog, we said for you to have this photochemical smog, you need to have strong sunlight to produce the radicals. You also need stable atmospheric conditions so that these radicals can stay for some time. Remember, we said you also need nitrogen oxides. You need the hydrocarbons. Remember, yesterday we saw that they generate the peroxide radicals, which form an important part of the process. So I think so the conditions for the formation of photochemical smog, we said we need a strong sunlight, and then the meteorological conditions should be stable for these radicals to play an important part in the atmosphere. Then we need the nitrogen oxide, we need the hydrocarbons, and I think the other thing we forgot here was we also need the ozone. Ozone is also an important component of this. So we looked at the cycle yesterday where we said the hydrocarbons and the nitrogen monoxide, so the hydrocarbons and the NOx emissions, this ones come from automobile. When you don't have complete combustion of the hydrocarbons, then they are likely to be emitted as hydrocarbon vapors. And then nitrogen oxide is still part of that, so it can still come from there. And then we say the hydrocarbons can be attacked by hydroxide radicals to form we talked about the peroxyalkali, which I think we showed with the formula. Maybe I'll just try to show you that. So in our equation, which I gave you yesterday for the formation of smog, we said that those radicals can still oxidize NO to NO2, which produces the brown fumes. The NO2 can also, in presence of sunlight, can be broken down to form, sorry, it's NO plus oxygen. And then I think we talked about oxygen. So we said oxygen can also combine, so oxygen atom can combine with oxygen to yield the ozone. So I think we talked about ozone depletion, using it during the process. So ozone can be formed during the process. And when this reaction occurs, it normally also leads to the formation of what we call aerosols and smog. So the organic compounds that we talk about They are referred to as PNA, which is just, so this one stands for, so PNA, I think I can show you the formula. It's supposed to be the peroxynitride. I think let me just see if I can be able to get the structure. So let me just see again, sorry. So this is the structure of that, the peroxide that we were talking about yesterday. So like this one is called peroxyacetyl nitrate. So this is the acetyl part, RCO. Then this is the peroxide, which is also still part of the nitrate part. So you talk about PNA. So these are just the peroxyacetyl nitrates that also play an important role during the photochemical reactions to produce a smog. I think we showed this in our equation when we were discussing about the same yesterday. So let me just go back to this. So we talk about PNA, that is the structure, peroxyacetyl nitrate, important hydrocarbons that take place, take part in the formation of photochemical smog. So you start with the hydrocarbon, it's oxidized to form the aldehyde, and then the aldehyde is oxidized further to form the peroxide. So you can be able to get that structure from the same. So this is just a repeat of what we said yesterday. So this talks about the effect of the smog. So the constituent of this photochemical smog, we said, are the organics, ozone, and nitrogen oxide. And so aldehydes, ketones, the PAN, which are just the peroxide, ozone, and NO. So what are some of the effects of the photochemical smog? I think we mentioned some yesterday. So they can cause irritation of the eye because of the nitrogen dioxide gas. And the irritation can also affect the air tract, which can lead to coughing, chest discomfort, fatigue, and sometimes this can also damage blood capillaries. And then ozone in itself, because we produce some ozone during the process, for the plants, it's not very useful. It can cause a reduction in the plant, leading to forest death, and also the foliage also dying. And why this one is harmful, we saw that when it combines with molecular oxygen, it will form, when it combines with molecular oxygen, it can form atomic oxygen. So it causes damages by reducing the amount of oxygen produced. So ozone can also damage materials because it easily reacts with the organics. So it can destroy materials, especially the dyes and the polymers, which are organic, through oxidation, which will lead to their decolorization. The same ozone, we also saw that it can also react with the hydrocarbons to form aldehydes and ketones. And these aldehydes and ketones, when they are oxidized further, they form that peroxyacetyl nitride, which irritates the eye and sometimes can also cause cancer. And then the only way of controlling this, we said, is by controlling the amount of NOx, the amount of hydrogen carbonate in the atmosphere to suppress formation of the smog. So to control formation of the smog, we need to take care of sodium, nitrogen oxide, the hydrocarbons, and the hydrocarbons NOx and ozone. So what we can control, which are cause of human beings, are the NOx and hydrogen carbons or hydrocarbons, which come from combustion of fuels. So if you can control that, then you can be able to control the formation of smog. So in the stratosphere again, where there is the water cycle, it's experienced by, we said, a low density, and then there is also where we have this life, most of these chemicals are stable, and they are going to have slightly longer half-life. So the major pollutants in the atmosphere, if you look at the skies, are the pollutant source are the aircrafts. When they fly into the atmosphere, they exhaust, they release the gases into the lower atmosphere. Of course, because of the density, we said some of these things might fall back. And when you have these organics, they can react with ozone, and this can reduce the ozone concentration because ozone is easily combined with the NOx and the hydroxide ion radicals produced during this reaction. So at this temperature, we have said when you increase the level of ultraviolet light, then you will favor the catalytic reactions that destroys ozone. So we are saying that what happens is that when you have ozone, ozone is a good gas because when it is in the atmosphere, we said it prevents us from getting into contact with harmful UV radiation. And when you create those holes, what will happen is that the holes will make this gas, ozone gas, come into contact with the atmosphere. So remember, we said this is what happens when you have UV. It can break oxygen into atomic oxygen. The atomic oxygen can combine with the oxygen to form UV, and when you to form ozone. When you form this ozone, this is good because it absorbs very harmful radiations from the sun. But again, in the presence of UV, the same ozone will break down to give oxygen and atomic oxygen. So again, it is destroyed. It is destroyed to form oxygen. When you create those holes, then the harmful radiations will get into contact with our skin, and these radiations have been known to cause cancer. So biologically, they are not very friendly. So in the stratosphere, we are saying that this ozone is constantly being created by the sun. It's being created and destroyed by the sun. So you can see in the presence of UV, we generate atomic oxygen. This atomic oxygen can combine with molecular oxygen to form ozone. So we are generating it here. But again, we can also break it. It can break down to oxygen and atomic oxygen. So it's being formed and destroyed at the same time. So I think we also need to know that we can also have other forms of reactions of this ozone in the atmosphere. I think we'll be looking at them later. And these reactions might involve reactions involving chlorofluorocarbons. So the chlorofluorocarbons, the NO2, can also deplete this oxygen in the atmosphere. I think we'll just show it shortly. So what are the effects of nitrogen oxide in the atmosphere? I think we have talked about this. So lack of a skin for nitrogen dioxide in the troposphere means that it may sink. Okay, so let me just see lack of skin. I think here there was a type, I think it's supposed to be zinc. So if you don't have a zinc, if you don't have something that can absorb nitrogen dioxide in the atmosphere, we are saying that it can slowly be introduced into the atmosphere. And I think we saw the effect photochemical reaction where we generate OH that reacts with this NO2 to form NO. I think we saw the cycle. So how does it enter into the atmosphere? So it enters by NO, which is formed by incomplete combustion, into the cycle. And we saw in our upper reaction that when you have ozone, then this gas can react with ozone and the concentration can decrease. So I think there's a brief explanation given here that in the first place, when you don't have ozone to form NO2, the NO2 can be attacked by oxygen. So the NO2 can be attacked by oxygen atom to form NO2. So I think this is a simple reaction. So when you have NO2 plus atomic oxygen, you can form two NOs. So two NOs can be formed. So the combined effect of these steps is to consume oxygen and ozone by converting them into molecular oxygen. So what is happening is that in the reaction that we saw up there is that you can have oxygen combining with molecular oxygen oxygen combining with atomic oxygen combining with ozone to form molecular oxygen. So there is this NO cycle. I think this one is talking about what we talked about there, that when you have NOx can also contribute to the removal of ozone. I think we saw this reaction. So there was a reaction here. So there was a reaction, if not here, I think maybe in yesterday's notes, where we were able to relate NO2. I think it was during the formation of photochemical, we were saying that this one breaks down to form atomic oxygen, and then the atomic oxygen was combining with ozone to form oxygen gas. So I think maybe that's what we wanted to mention here, that NO can also play an important role in reducing the amount of ozone. So it can lead to that. When you have NO2 and it breaks down to form NO plus oxygen atom, the oxygen atom can combine with ozone to form oxygen gas. So what we are saying is that when oxygen combines with ozone, the reaction is normally a slow reaction because it requires a lot of energy. And when you have NOx, it can catalyze this reaction by increasing the rate. So here we're talking about the zinc. We've talked about the zinc. This is something that will remove NO generated. And how do we remove it? So the zinc for this, we said, is you can oxidize this by oxygen to form the NO. I think maybe just to take us back. So I think we are talking about there was this place where we had the radicals. Yeah, so I think so this is the zinc that we are talking about. So you can be able to remove this just by reacting it with the hydroxide ion. So when you talk about the zinc, this is something that removes some a chemical from the environment. So we have so for this that is generated, it can be converted to nitric acid, as we saw up there. And in the soil, there are some bacteria that can be able to convert NO3, NO2 into things like ammonia. and then these are taken up by the plants. So if we continue to use nitrate fertilizers, then these ones, they also tend to increase the release of this nitrogen oxide from the atmosphere. And what happens is that similarly, when you when aircraft releases the same, they can also enhance the nitrogen cycle. So we have talked about this ozone layer. So what is it? So it's a layer which is found in the lower stratosphere, and we have said this ozone layer is important in preventing harmful radiation from reaching the Earth's surface. And we say these harmful radiations, when they reach, they come into contact with our skin, they can cause what we call skin cancer. So the concentration is normally expressed in what we call a Dawson, but I think we don't need to memorize this. So it's measured in terms of the thickness of the layer under standard condition of temperature and pressure. So the normal condition for this ozone varies between 3,000 to 400 Dobson units. So a Dobson, so this Dobson unit is just equivalent to about 0.07 centimeter thickness of the layer under standard conditions of temperature and pressure. So how is it formed? So how do we form ozone? So to form ozone, oxygen breaks down to form the oxygen atoms, which we explained. So in presence of UV radiation, you can break oxygen to form oxygen atoms. And then these oxygen atoms, when they combine with oxygen molecule in presence of a catalyst, they will generate the ozone. So we talk about a third body. So this acts as a catalyst, just to increase the rate for this reaction. And once it is formed again through this process, this same ozone can also be depleted. So this is what we should know. The formation is oxygen breaks down to form atoms of oxygen. The atom of oxygen can combine with molecular oxygen to form ozone. But it can also be depleted. To deplete means you remove the concentration. And it is normally depleted by nitrogen oxide and what we call chlorofluorocarbons. I think we'll revisit this one. The chlorofluorocarbons, which are used in refrigerators, can cause the depletion of ozone. So for the NOx, we saw this when we are talking about the reactions up here. If not up here, I think it was yesterday during formation of so during formation of smog, we talked about the NOx, which can pick oxygen from ozone. Where you have NO plus ozone, you get nitrogen dioxide plus molecular oxygen. So the oxide can remove this one. I think maybe in the notes for formation of photochemical smog, you have that particular reaction. So the major depletion of ozone, as we shall see, are the NOx, the nitrogen oxides, and the chlorofluorocarbons. Chlorofluorocarbons are compounds consisting of chlorine, fluorine, and carbon. And again, they do this through what we call a free reaction, free radicals, as we are going to see. So these CFCs are chemicals that normally contain carbon, fluorine, and chlorine. They are used in refrigerators as coolants, because they can easily convert from solid, from liquid to gas. just by absorbing energy, they can be able to be converted from liquid to vapor, and the same vapor, when it's passing through the chamber for cooling, heat exchanger that is, the same vapor can lose energy. When it loses energy, it will be converted into liquid. So they are normally used in refrigerators. They are also very good organic solvents, and they are also used during the formation of plastics. So we talk about the chlorofluorocarbons, which also play an important role in the depletion of ozone. I think we are going to see how these reactions happen. So the chlorofluorocarbons, they can be absorbed, so they absorb the radiation even at low concentration. And the problem with them is that they have got very long half-life. They can stay in the atmosphere for a long time. And when they stay in the atmosphere for a long time, they can take part in the free radical reaction, and in the process, cause ozone depletion. So how do these hydrocarbons participate in ozone depletion? So we have, when you have chlorofluorocarbon, when you have CFCl3, so this is a compound, you have carbon at the center. You can be able to connect this if you did organic chemistry. So you put carbon at the center and fluorine and the chlorine on the sides. You can form this one from methane. You can form this one from methane. You can form this one from methane just by replacing the hydrogen, and you can form this from methane just by replacing hydrogen and chlorine in the atmosphere. So we have this equation here where you have CFCl3. When you have UV light, this one can break down to form CFCl2. Sorry about this note. This O is not supposed to be there. So the O is not supposed to be there. When it breaks, it should give you CFCl3 and atomic chloride. So it's a free radical reaction. What's happening here is that you are breaking a carbon chloride bond. You're breaking a carbon chloride bond, and when you break a carbon chloride bond, this is what you get in the process. So I think what we are saying here is you have that. So you have, on one side you have that. I'm just trying to explain that. And then the other bond is a Cl. Chlorine. You have another chlorine here, a chlorine here, and a chlorine here. So what will happen is that, so in this reaction, you're breaking this bond here. So you break this bond, and when you break the bond, the shared electrons are taken by chlorine, and this dichlorofluorocarbon radical. So this is what you get here. So I think, sorry about that, this oxygen is not there. So this is what you generate from there. And then the atomic chlorine. The atomic chlorine will now react with ozone, where it will pick an oxygen from ozone to form ClO, plus oxygen gas. To form ClO plus oxygen gas. So this is what you get over there. Now there is what we call a net reaction. How do we get a net reaction? We get a net reaction by adding these two reactions. You get a net reaction by adding these two reactions. Remember, we have said this one is not there. This was a typo. So this one is not there. So when you just add this, like the way you add simultaneous equation, you'll find that this will cancel with that, and the other effect that we are going to see for this is that the effect that we'll be having here is that we'll just be converting our ozone into oxygen gas. So the net effect for this reaction is conversion of ozone into oxygen gas. Now it's important to know that the pollution caused by the chlorofluorocarbons and the nitrogen oxide takes place in the stratosphere where we have life, and it normally happens to generate the NO2 and the NO, which are injected directly into the atmosphere by the aircrafts. Now, we need to know that when you release the CFCs and the NO2, they will tend to affect the concentration of ozone in the atmosphere. So the question could be, what are the effects of creating the ozone holes? I think we have just tried to mention one of them, that when you do this, when you create those holes, then there is those harmful radiations that can come into contact with the human beings and other creatures. And we say these radiations are normally not good. And when they come into contact with our skin, they can cause skin cancer. Some of them have also been known to affect the eyes. They can cause what we call cataract and other infection of the eyes. So it has actually been estimated that for every 10% loss of ozone, this leads to about 20% increase of diseases associated with skin cancer, breast cancer, since the UV is known to damage the DNA cell. So I think there's a lot of stories here, but I think what we're saying is that depletion of ozone causes skin cancer. And remember, we also said that the same UV light can also lead to reduction in leaf size, and also affect the production, because we know proteins are normally formed through reactions involving, when we talk about DNA and so on and so forth. So when you affect formation of proteins, you're also likely to affect formation of other compounds that take place, that participate in the formation of chlorophyll. So when you are asked, how do you control ozone depletion? So to control, again, ozone depletion, we can just say it is just to remove the production of CFCs and NOs. CFCs and NOs, any reaction that will remove this will normally take care of ozone depletion. So we can use alternatives. So to control the depletion of ozone, then what you need to do is to decrease the production of CFCs. And instead of using CFCs, we can use other friendly products in the coolant, which don't break down to produce those unfriendly radicals. So I think the most important thing is we just use friendly or safe methods in refrigerators and also to kill insecticides. So they're also found in pesticides. So what you may just need to do is instead of using the chemicals, you can use friendly methods. One of them could be biological to control the insecticides. And then the other thing that has been mentioned here is that the glass roof of greenhouse is normally permeable to radiation from the sun. So once inside the greenhouse, these radiations strike the surface and are transformed into heat. So I think we need to control this. I think the main thing that we are saying here, to control ozone depletion, we just avoid the use of these chlorofluorocarbons. We have avoid the use of those chlorofluorocarbons. And what is being said here is that I think they are trying to bring about the effect of what we call global warming. When you have some of these gases that are present in the atmosphere, allow the radiation from the sun to strike the surface, and when after striking the surface, they are normally reflected back. So if you have too much of these gases in the atmosphere, after the, so we are saying that, so we have layers of these gases here. So after they have struck the surface, they will be reflected back. Now, if you have a layer of some of these gases, which they are referring to as greenhouse gases, these gases will prevent these radiations from going back into the atmosphere, and the effect would be increase in temperature. So this is what actually referred to as greenhouse effect. And the gases which cause this are shown here. So I think here we have just introduced another effect of these CFCs. Apart from depleting ozone, they are also major contributor to what we call the greenhouse gases. The gases which prevent radiation of the sun after striking the surface from going back into the atmosphere. So the gases, the major one is carbon dioxide. I think you have heard people talking about global warming. So global warming is normally caused mainly by carbon. And then these are the other gases which will cause the same. So there are sources of these gases. I think we don't need to repeat this, the advantage of this. Sources of carbon dioxide, we know we get it from automobile emission, combustion of charcoal. Nitrogen dioxide, we talked about the source, also fuel. CFCs, we have said that the source. For the CFCs, we said they are used in refrigerators. They are also good solvents. Ozone just occurs naturally in the atmosphere. The hydrocarbons, methane, we get them by action of bacteria on some plants, and sometimes also from the decomposition of organic matter. Volcanic activity also emits carbon dioxide. Human beings, livestock, we know we also breathe out carbon dioxide. And so I think what you can see here, we are talking about sources of CO2, what increases the amount of CO2. So we have things like deforestation. We said when you cut down trees, this will lead to increase in concentration of carbon dioxide, because at night, we know that plants use CO2 to form food. So what happens is that CO2 is consumed. So if you have, if we don't have plants, then they'll not be able to take in CO2 at night, and the concentration is likely to increase. So livestock also breathe out CO2, so this will also lead to increased concentration of CO2. The same CO2 can be gotten from burning of automobiles. Volcanic emission also releases CO2, and this is how we increase the concentration. So to control this, you just need to control the amount of carbon dioxide released in the atmosphere. You also need to control the nitrogen oxide and the CFCs, as has been mentioned here. So what are the effects of global warming, or what we refer to as greenhouse effect. When the temperature of the atmosphere rises beyond what is expected. So one of them has been the increase in what we call sea level. So the sea level increases. Why does this increases? Because when the temperature is high, then most of the ice will melt. And when it melts, it means the level of the sea will increase. And then we also have evaporation of water from aquatic system. When the temperature is high, and when this happens, the ecosystem in seas can also be affected. The other problem of global warming is that we have a change in weather patterns, and when the change in weather pattern occurs, this can also lead to food insecurity because farmers will not know when to plant. I think we have seen this thing happening. Predicting the weather has become a problem, and if you plant during wrong season, it's likely to cause this one is likely to cause food insecurity because plants will not grow well. And then from this global warming, as we have said, it has been estimated that when the temperature increases, this will lead to melting of glacier and disappearance of rivers and lakes. How do they disappear? Because water evaporates. So what is the effect of the same on plants? I think we have said how does increase in temperature affect the plants? So I think some of the effects have been given here. So carbon dioxide fertilizers, plant biomass may increase by about 30% because of increase in concentration of CO2. And then nitrogen content also in plants. Plant growth also is high. Okay, in high hydrogen, in high carbon dioxide concentration, have less nitrogen and more carbon. So it also, when you have more carbon, it means the concentration of the other nutrients will decrease. And then the same effect of global warming is we also have increase in the decomposition, leading to release of more carbon dioxide. High temperature causes plants to die when they decompose. Then we end up releasing more CO2 and the effect increases. It's also an increased threat of pests when temperature is high. Most of these pests will will have more of these pests, and they are likely to affect the plants. And then we have also evaporation of water from the soil, and this can also affect the development of the plant. So for the human beings, when the temperature increases, the temperature can also bring about infectious diseases like malaria and yellow fever. I think this one is known. Most of this, the vectors of this disease, they survive well when the temperature is high. And then for the wildlife, how does it affect the wildlife? I know for the wildlife, if you affect the plants and other creatures in the forest, you are likely to affect the wild animals. So abatement of greenhouse effect, that means how do we reduce this? I think we had talked about this. So to reduce the greenhouse effect, it means, so to control greenhouse effect, it means just control the production of these gases. If you control these gases, then you'll be able to control the greenhouse effect. And this is what they are talking. So you develop alternative sources of fuel apart from fossil fuel, which when burned, they produce carbon dioxide. We have things like wind power, biogas, use of electric cars, using of hydrogen vehicles, solar vehicles, and so on and so forth. And then you can also try to reduce deforestation so that these plants can be able to take up carbon dioxide. You can look for alternative source of CFCs. And then the other reason is also to try and stabilize the population. How does it affect the global warming? Because remember, we have said human beings and livestock, they give out CO2 during breathing. So if you control the population, you can also control the amount of CO2 produced. And then we try to control emissions of NOx. Remember, we talked about catalytic conversion, whereby these gases, when you have the NOx, instead of generating NOx after combustion, you can convert the NOx into NO. So you can convert the NOx. What you're saying is, instead of burning this, instead of burning and getting this, sorry, the pen, you can now have a catalytic chamber when the N, where the N is controlled, the NO2 is converted into that, plus oxygen, which are friendly. So these ones don't affect, don't cause global warming. So you can get this. I think we talked about this. And then just reduce the use of fossil fuel, and that will be it. I don't know if there is any question up to there. Any question up to there? Let me see in my additional notes if we have something that we can. Let me see if I have something here. So I think this one. So I think you have this notes which talks about acid rain. We had looked at it yesterday. The smoke and whatever. So I think there is something here which talks about the greenhouse effect and the gases, what it is, greenhouse gas. So these are the gas that absorbs and emits radiation within the thermal infrared range. And the effect of this is just to cause the increase in temperature of the atmosphere. Let me just show you what we were talking about here. So this is what happens. So we have the radiations from the sun. They normally hit the surface. When they hit the surface, they are reflected back. But you can see when you have these greenhouse gases, after they have hit the surface, they are not reflected back, but they are blocked from going back into the atmosphere. And this is what now causes the greenhouse effect. When you have those gases, they'll prevent this radiation from going back. And the effect is an increase in the temperature of the Earth. So the major component of this, we have talked about water vapor, we have talked about carbon dioxide, we have also talked about the CFCs. Now, carbon dioxide, I think here we are just talking about the source. It is used in industries, food industries, beverages. I think you've heard about carbonated drinks. So it's normally put in beverages, wine making, and so on and so forth. And even fire extinguishers, some of them are made by use of CO2. And then it's also used as a solvent in separation techniques and also in agricultural activities. And then I think I just wanted to revisit these reactions of CFCs. So this is the other notes on greenhouse effect. I know I'm moving a bit fast, but you can see the reaction that we are talking about. So when you have these CFCs, it breaks down. When it breaks down, it forms CFCl and a chlorine radical. And this reaction can still repeat itself. So you can have a case where it breaks to form that. If you have a similar compound with 2 fluorine and 1 chlorine, it can still break down to form CF2Cl plus Cl. And then there's a reaction that we talked here. We say that the atomic chlorine can combine with ozone to form ClO plus oxygen. And then the COL can pick oxygen. When it picks oxygen, it can form the oxygen gas plus Cl. I think this is the reaction that I wanted to talk about. Now, when you add this reaction, just like you're adding a simultaneous equation, when you add this, what will happen is that things which are on the different side of the equation will cancel out. So this cancels with that. And then this chlorine cancels with that. So the net effect is you add this, you get 2 oxygen, 2 ozone, and then in the process, you form oxygen as shown in that equation. So this is talking about the oxygen, what it causes. I think we have said the effect of the same. So I think this is also another reaction showing the same. That one, we have CFCs which are emitted and reaches the ozone layer. This is the ozone layer here. So when you have these gases here, they'll deplete this ozone layer. And then when they deplete the ozone layer, these harmful radiations will be able to hit the surface. And then when they are reflected backwards, they can't go because of the same layer of these gases. So this is what causes the warming, I think, in terms of explaining the same. So I think you could be able to see that. We have talked about the effect. So effect of depletion of ozone, we have said the radiations, they cause cancer. Exposure of this can also lead to affect the eyes and cause what we call cataract. I think can affect the vision. And then we also say it affects DNA. And when it affects DNA, we know it's the one responsible for the formation of the chromosomes. So when they are affected, then you can have what we call mutation. So I don't know if there is any question up to there.
Hello, Prof.
Yes.
I had a question.
Yes.
Does it now imply that global warming means the same thing as temperature inversion?
Just the same thing, yeah. Changing the temperature pattern, the same thing. Global warming, the same thing. Global warming, greenhouse effect, those are the same thing.
Okay, thank you.
Yeah. Mm. So can we still continue, or people want to Can we continue or we continue tomorrow?
Tomorrow.
Yeah, let's continue tomorrow so that we plan.
Challenge
So
is some of us we have another class for physical chemistry on Mondays, 7 to 9. So I don't know if we can maybe you put it on Tuesday kindly, Prof. So that
let's put it on Tuesday.
thank you, thank you.
Tuesday, and then Tuesday we can look at pesticides. Tuesday, let us look at pesticides, and then I think I wanted us to look at pesticides. And we'll also look at the extraction of metals and how they affect pollution. So maybe let's see how we can do that in the course of the week. But I know Sunday is a bit tricky because people have had a long day. We have just come from church and so on and so forth. And I can see when the numbers have really fallen. We're just remaining 4. I saw now you are 4 plus myself, and I think we are about. I think we have 4 plus myself. So I think okay. So I think let's just stop there for now, and then we can pick up tomorrow. Or we can pick up on Tuesday.
Thank you, Prof.
Thank you. Bye. Thank you.
Good night.
Ala, hii lesson imeisha.